Welcome to Sciencepect, where we explore the most exciting frontiers of science, technology, and space. Today we're heading deep into the outer solar system to a place that might hold the key to one of humanity's oldest questions. Are we alone? We're talking about Europa, one of Jupiter's 4 largest moons. For decades, this frozen world has captured the imagination of scientists and science fiction writers alike, primarily for one incredible reason. Underneath its miles-thick shell of ice, there's believed to be a vast global ocean of liquid water, and now the hunt for life in that hidden ocean is officially beginning. NASA's highly anticipated Europa Clipper mission is launching soon, specifically designed to investigate this tantalizing possibility. In this video, we'll dive into why Europa is such a prime candidate for life, the incredible goals of this mission, the cutting-edge tech it's carrying, and what its findings could mean for our understanding of life in the universe. So why Europa? Out of all the moons and planets in our solar system, what makes this particular icy world so special? First, that ocean. Evidence from previous missions, like Voyager and Galileo, strongly suggests its existence. Europa's slightly elliptical orbit around Jupiter causes powerful tidal forces. As Jupiter's massive gravity stretches and squeezes Europa, it generates heat deep within the moon's interior, a process called tidal heating. This internal warmth is believed to prevent the deep ocean from freezing solid despite the incredibly cold temperatures on the surface. Furthermore, observations from the Hubble Space Telescope have hinted at the possibility of water vapor plumes erupting from Europa's surface, essentially geysers shooting ocean water into space. If confirmed, these plumes could offer a way for the Europa Clipper to sample the ocean's composition, without ever needing to drill through the ice. Combine the potential for liquid water, internal heat, necessary chemical ingredients from a rocky core, possibly organic compounds delivered by meteorites or volcanic activity, and you have all the key ingredients scientists believe are necessary for life as we know it. Enter the Europa Clipper. This isn't just another flyby mission. While it won't land, it will orbit Jupiter and perform nearly 50 close flybys of Europa between 2030 and 2034, swooping as low as 25 kilometers above the surface. This orbital strategy is crucial because Europa is bombarded by intense radiation from Jupiter, which would quickly degrade an orbiter or lander directly around the moon. By orbiting Jupiter and making quick passes, Clipper minimizes its radiation exposure. The primary goal is clear: confirm the existence and nature of the subsurface ocean. But the mission has several other critical objectives. 1. Characterize the ocean. Use instruments to measure the ice shell's magnetic response and variations in Europa's gravity field, which can reveal properties like the ocean's depth, salinity, and size. To investigate the ice shell, determine its thickness, structure, and how it interacts with the ocean below. Are there areas where the ice is thinner or where melting, freezing activity is occurring? 3. Analyze composition. Study the chemistry of the surface and any potential plumes to look for salts, organic molecules, and other building blocks of life that might originate from the ocean. 4. Map the surface. Create high-resolution maps to understand the moon's complex geological features, such as ridges, cracks, and chaos terrains, which are evidence of past or present activity. 5. Identify future landing sites. The detailed data collected by Clipper will be essential for planning any potential future missions, including landers or even submersibles that could explore the ocean directly. To achieve these ambitious goals, Europa Clipper is equipped with a sophisticated suite of 9 science instruments. These are some of the most advanced tools ever sent to the outer solar system. There's a reason the radar for Europa assessment and sounding. Ocean 2 near surface. So a radar instrument will probe through the ice to estimate its thickness and search for liquid water layers or even the sea floor below the ocean. IceMag, the interior characterization of Europa using magnetometry, will measure Jupiter's magnetic field interactions with Europa. A salty, conductive ocean would create a unique magnetic signature that IceMag can detect. Helping confirm the ocean and its salinity, Sciencepect's the mass spectrometer for planetary exploration. In SUDA, the surface dust analyzer, will analyze the composition of gases and particles around Europa. If plumes exist, these instruments can directly sample the ocean water expelled into space. It's looking for organic molecules and other signs of potential habitability. The Europa Imaging System, EIS, will provide high-resolution images to map the surface geology and search for evidence of recent activity or plume sources. ATHMIS, the Europa Thermal Emission Imaging System, will measure Europa's surface temperature, looking for warmer spots that could indicate recent geological activity or the presence of plumes. There are also instruments to study the plasma and dust environment around Europa, which can provide further clues about the Moon's interaction with Jupiter and the potential venting of material from below. The data collected by Europa Clipper will be revolutionary, confirming the existence of a vast, habitable potential ocean on Europa would fundamentally change our understanding of where life could arise. It would demonstrate that liquid water, a key ingredient for life, might be far more common in the universe than previously thought, perhaps existing under the icy shells of many other moons around gas giants. Finding definitive evidence of past or present life, perhaps simple microbes, under Europa's ice would be one of the most profound discoveries in human history. It would prove that life didn't just arise on Earth, implying that the universe could be teeming with biological activity. Even if Clipper doesn't find direct evidence of life, the mission will tell us if Europa is habitable, laying the groundwork for future missions that could explore the ocean directly with robotic submarines. The journey is long. Arrival isn't until around 2030, but the potential payoff is immense. What do you think Europa Clipper will discover? Let us know your predictions in the comments below. If you're as excited about this mission as we are, make sure to give this video a thumbs up. And don't forget to subscribe to Sciencepect for more cutting-edge science, technology, and space content. Hit that subscribe button and the notification bell so you don't miss our next deep dive. See you in the next video.